Okay, we want to look at this problem here, which involves the application of derivatives. Now, the question reads, find the dimensions of a rectangle with a perimeter of 300 meters with an area as large as possible. So in other words, that gives us a maximum area. So now, to answer this question, I would actually advise that first, put in a diagram what you envisage by what you are reading here. For instance, here I can see that we are told that this shape here is a rectangle and it's got a perimeter of 300. So if I actually drew a rectangle here, I have a rectangle that I've just drawn there. And if I put the dimensions to this rectangle, say this side is x and this side is y, that makes this side x also and this side y. So now the question says the perimeter of this is equal to 300. That means perimeter is the distance right around the shape, and if I add x plus y plus x plus y, that should give me 300. So I can see here, I can have an equation which says 2x plus 2y is equal to 300. These two sides plus those two sides should give me 300. And I can quickly see that this formula, if I divide throughout by 2, I can have this as x plus y is equal to 150. So if I call this equation number 1, so I've formulated from the information there, I've actually formulated an equation. Now, the question then spoke of area. It says, I must find the dimension that will give me the maximum area. So then the next question I should ask myself is, how do I calculate the area of a rectangle? The area of a rectangle, if I denote the area with the letter A, the area of a rectangle is given by x times y. So I can have, say, this is another equation that I have. And I know for me to get the maximum value, remember, for you to get the maximum value, you can find the derivative and equate that derivative to 0. So in this case here, I have area being given by x times y. So I can be able to take advantage of the first equation here so that I can express area in terms of a single variable. So from equation number one, from equation number one, I can see that y can be made subject such that I have y is equal to 150 minus x. And if I substitute, and let's call this equation 3, if I substitute this equation 3 into equation 2, then I can have this area being given as now x into y, which is 50 minus x, like that. And if I expand this, that's the same as a is equal to 150 x minus x squared. So I have an equation, or I have a formula to calculate area, which depends on one variable x. So I am able to find the derivative of a with respect to x. And if I differentiate that, what I'm going to get is 150 minus 2x. And remember, I said to get the maximum values or the maximum dimensions, we must equate the first derivative to 0. In other words, this simply means that 150 minus 2x should be equal to 0. And if I solve for x here, that gives me 2x is equal to 150. Therefore, divide by 2, x is equal to 75. So we have found the dimension of x. So that means this side should be 75 meters, right? Now that we have x, remember we already formulated an equation which says y is equal to 150 minus x. So we can calculate y. Y is equal to 150 minus x, which is 75. And that gives me also 75. That's 75 meters. So that means y is 75 meters. And this appears to be a square. So the question some students may ask is, but this is not a rectangle. The truth is, it is actually a square is just a special type of a rectangle. So it is actually a rectangle. Remember, a rectangle has got two opposite sides equal, and a square does have the same thing. The only difference now is that it has got all the four sides being equal, but otherwise it is a rectangle, just a special type of a rectangle with all the four sides being equal. Okay, so we have found the dimensions. Now, kindly subscribe to this channel, like and comment so we can be able to also respond to your comments with more videos that will help you to answer most of the questions that you have. Thank you.